Welcome to this week's content, where we take a look at using P-charts to monitor binomial data across healthcare systems. In Chapter 6, we looked how to evaluate performance where the variable of interest was on a continuous scale. And we were able to use X bar and R bar charts to do that. But sometimes we have a yes or no kind of data. Did it work or didn't it work? Was the treatment effective or wasn't it effective? And so when it's a yes or no kind of data, we call it binomial data, and we need to use different tools to monitor it. So did the events meet a defined standard? Ross has 6 steps for using SPC for binomial data. And of course, the first one is to collect the data. But I think we have to back up before that and define what we mean by conformance, because that could be subject to interpretation, such as if you have a delay in starting a medical procedure. I mean, that could really vary. So sometimes conformance measures are extremely clear, like did we operate on the correct site? Did we operate on the right eye, which is the correct site, versus the left eye where we made a gross error? So defining that conformance prior to collecting the data is really key. What do we mean by a delay? What do we mean by conformance? And then step 2 is calculating the descriptive statistics. If we're just looking at one sample, and we want to look at the proportion of non-conforming rates within that sample, we look at that as a ratio or a percent. But quite often we want to get the average across all samples, and we call that a p-bar. So defining what it is we want to do from the get-go in terms of success and failure, and what we want to collect in terms of data, is it within one sample or across a number of samples, makes a difference. There are basically 2 types of control charts, p-control charts, that we can use, and it depends on the type of sampling that we do. We might want to make a control chart to present a non-conformance rate, which is a p-chart. Or we might want to look at the number of non-conforming events, which is an NP chart. So it's basically a count of events versus the percentage. But the decision is really based on the sample size. If we're performing a number of samples across time, and the sample size varies, then we have to use a p-chart, as a percentage across time will account for the changes in the sample size. If we have an even sampling process, so it's the same sample size across time, then we can use an NP chart. So we can look or track the number of non-conforming events as opposed to the percentage. And I thought Ross had a really nice example of this in talking about how if it's a different sample size from one time point to another, a percentage could really misrepresent whether or not there's a problem or not. If you have a sample size of 2 and 1 is non-conforming, that's 50% of your sample versus a sample size of 10 where you have 1 and it's only 10%. So when you think about it, it really makes sense that if we're counting events, the sample size needs to be the same across time, and then that will dictate the type of charts that are available to us. So now we need to graph the actual and expected performance and interpret that performance. And on these examples, we have conveniently calculated our upper and control limits, and I skipped over that. We'll go over that in a little bit. But in these examples, as we look at the patterns, we need to decide, is there a problem or not? And in the first example, A, it represents a stable system, and it looks at the percent of acute myocardial infarctions for those patients with AMIs who receive aspirin within 2 hours of arrival to the emergency room. And the first one is a stable system in that it's within the control limits, but I think you have to ask yourself, is 20% an acceptable level? To me, it's really not. It needs to be lower. So we're looking at historical data and calculating those upper control limits, and we're not really comparing, in this example, to national benchmark data. So that's a whole nother question. But if we simply looked at the pattern, it is stable. In the second one, we've got more of a control breach, and that in the sample 3 goes above the control limit. So we need to go back and look at what happened in that particular time period where we reached an all-time high of close to 25% of patients are not receiving ASA in that particular time period. And then it drops off. So it just begs more questions than answers when you look at this data. For example, C and D, in C we see that there's a very worrisome upward trend. And so even though it's still within the control limits, we need to investigate and find out what has changed. Why is it that the data is going up? Has there been a change in perhaps the emergency department physician staff, that they're not ordering that? Or are our orders not going through somehow? Is something getting missed in the system? Again, we need to investigate and find out what's going wrong. And then in graph D, we have a nice drop-off, but we really want to know what happened. Why are we doing so much better in the last half of this graph? So after week 10, it looks like perhaps we had some education of staff or a change in protocol we let everyone know about that automatically puts this medication order into place or something. Anyway, we need to find out, what are we doing right in this one, just like the switch book. And the other two examples that Ross has in the book is graph E, which is within compliance, within the upper control limit. However, it's got this really interesting seesaw pattern, which actually we've seen throughout all these graphs. And so you need to ask yourself, why are the rates lower on the even weeks than they are on the odd weeks? Was there something going on in those even weeks that explains that? Is the staffing different? Typically, the way we run nursing schedules is that there's a pattern, and it's usually a pattern over every other week. We do 2-week schedules. So it really begs the question, is there something going on with the staffing? And then graph F is similar to D with a downward trend, except there's a dramatic drop at week 7. So again, what are we doing right? And why is there this seesaw pattern again? So you can see that these graphs never give you all the answers. They just raise a number of questions that you need to be alert to. So again, to summarize, after looking at those examples, is that we need to investigate any instabilities and improve as needed. So looking at those control limit breaches, the trends, the patterns, going back to Short's rules of when data points are clustered above and below the line, or you see an upward trend of so many points and so forth, they're really helpful in identifying patterns that need to be investigated further. So is the system unstable and in need of correction, or is it stable and still in need of correction? Again, back to maybe it's stable, but are we hitting the benchmark that we really want to hit? And then when we correct that, was the solution effective? So going back and looking at what happens after we have a course correction, and employing the PDCA cycle that we all know and love from quality improvement. So let's look at the example from the book about the accuracy of surgical coding in a department. So these are surgery procedures that are coded by people with expertise in this area, and it's really critical so that we can have accurate billing. So we've got our sample of 50, so it's a same sample over time for each month. So we can do a count as opposed to a percentage if we'd like. And then we've got the number that are incorrect. And then you see over in the right-hand column then, the book has used a percentage over each month, and then there's an average percentage at the bottom right-hand corner. So back to our upper and lower control unit calculations for this example. We've got the mean percentage, which we've calculated by dividing 41 over 600, or the total sample size, and that equals 0.0683 or 6.83%. And then to calculate the upper control limit for P, we have that mean percentage plus 3. And the reason we're using 3, I didn't mention before, is that this is along the lines of 3 standard deviations, which will give us 99 point something percent of the normal distribution curve within that sample. So we want plus and or minus 3 times the square root, again, of the mean proportion times 1 minus that mean divided by the sample size within each sample. And that's a consistent sample of 50 over time. So the upper control limit is 1.7%, and the lower one is, oh no, I'm sorry, it is 17%, and the lower limit is 3.8%. Have to think about those decimal periods before we say the percent. And so here is the P chart that we have come up with from those calculations. And you can see there's the upper control limit, which is 17.5% in green. And we see there's 1 point in July that's quite a bit over that. And then the lower control limit is 3.8%, or nearly 4%. What it looks like when you look at this is that there might be a seasonal variable when we examine the chart. It said July is over the upper control limit, and so it really makes you wonder, what was going on in July? Was it because of the new residents coming on board that it just raised havoc in terms of coding, or did the coders go on vacation in July and August? Anyway, there may be other variables involved. It might be that they switched systems, their information systems or something, with the medical records in July. Again, we just have to go back and investigate why we've got this outlier in the summer. And it would be interesting to look to see if it occurs every year, if we went back and looked at old data, if we had the time and resources to do that. Ross makes a really good point in the chapter when he talks about something called gaming the data, or just being aware that sometimes a downward or upward trend to our benefit, if it's sudden, may indicate that people are simply capturing the data in a different way. And it may be very well intentioned, or it may not. I have an example of this from Swedish. This was actually just a rumor that I heard. But when we were looking at hand washing rates, one way of looking at whether people are washing their hands or not is by looking at how much gel they're using outside of the rooms. And I heard via the grapevine that as our rates got very good, that people were actually taking those gel dispensers and squirting out the gel, which would skew the data to look like we were washing our hands more than we were. So if there's a sudden downward trend, or if it goes to 0, if you're looking at incidence of things that you don't want to happen, then one needs to perform a close audit of records to see what's really going on, or do an independent audit. For example, in that case, then, even though it's time and expense, you might want to